Picture this: a fiery ball of gas, 93 million miles away, begins to behave oddly. It's the sun, the heart of our solar system, and something unusual is happening. The sun, our closest star, is a marvel of cosmic consistency. It's a massive nuclear fusion reactor, converting about 600 million tons of hydrogen into helium every second, producing the energy that lights and warms our world. It's been doing this for about 4.5 billion years, and it's expected to continue for another 5 billion or so. Typically, the sun's surface temperature clocks in at around 5,500 degrees Celsius, while its core blazes at a staggering 15 million degrees. Its magnetic field, extending far beyond the outermost planet in the solar system, holds a delicate balance, influencing everything from the formation of sunspots to the eruption of solar flares. But recently, scientists have been scratching their heads over some peculiar solar activities. Some of the sun's numbers aren't adding up. The surface temperature has been fluctuating, straying from its usual average. The solar wind, a constant stream of charged particles the sun emits, has been showing irregular patterns. And then there's the matter of the sun's magnetic field. It's been acting up, deviating from its expected behavior. These deviations might seem minor, barely a blip in the grand scheme of the cosmos. But remember, we're talking about the sun. Even the tiniest of changes can have significant implications. The sun's behavior directly affects the Earth and all life forms residing on it. It influences our climate, dictates the behavior of our technology, and even impacts our health. So, when the sun starts acting out of character, we have to sit up and take notice. We need to sift through the data, scrutinize the numbers, and decode the cosmic mystery that's unfolding right before our eyes. But what could cause such strange behavior in our sun? Could it be a solar flare or a solar storm? And more importantly, how could it be affecting us? Solar flares and storms, they might sound like science fiction, but they are very real and quite fascinating. Hailing from our sun, these celestial phenomena are powerful bursts of radiation that can send shockwaves through our solar system. To understand solar flares, picture the sun's atmosphere, a complex system of magnetic fields, charged particles, and plasma. When magnetic energy that has built up in the solar atmosphere is suddenly released, we have a solar flare. Imagine the energy of 1 billion hydrogen bombs being unleashed in just a few minutes. That's the sheer force we're talking about here. Now, solar storms, also known as coronal mass ejections, are a bit different. They occur when the sun releases a gigantic bubble of plasma, composed of electrons, protons, and atomic nuclei, into space. This bubble, or cloud, can be larger than the sun itself. If you could fill 1 million Earths into the sun, imagine a cloud that could encompass all that and more. That's the scale of a solar storm, but how often do these events occur? Well, solar flares happen more frequently, often several times a day. However, most are too weak to significantly affect Earth. Solar storms, on the other hand, are less frequent, but potentially more impactful. They occur roughly 3 times every solar cycle, or about once every 4 years. And the effects of these phenomena? They range from beautiful auroras at our poles to potential disruptions in our electrical systems. Yes, the same flare that paints the sky with stunning colors can also cause a blackout on Earth. These phenomena also affect the sun itself. They contribute to changes in the sun's magnetic field, variations in solar radiation, and can cause sunspots, temporary areas of reduced surface temperature. So, could one of these solar phenomena be causing the sun's unusual behavior? Let's delve into the data. Numbers never lie, and in this case, they tell a fascinating story. Let's dive into the data that's causing a stir in the astrophysics community. The sun, our very own star, has been behaving in a way that's quite out of the ordinary. The data we've gathered over the past few months shows a significant increase in solar activity. Our solar observatories have been recording an uptick in the sun's electromagnetic radiation. The sun's average X-ray flux, which is normally a predictable, steady stream, has been spiking erratically. Similarly, the sun's radio wave emissions have been oscillating in a pattern that's far from the norm. Now, let's talk about solar flares. These are sudden flashes of increased brightness on the sun, often near its visible surface. The number of solar flares, measured in terms of their X-ray output, has seen a drastic surge. We've recorded more than double the typical number of solar flares in the last quarter alone. But it's not just the quantity of these solar flares that's intriguing, it's also their intensity. The data shows a marked increase in the strength of these flares. We measure this in terms of C, M, and X classes, with X being the most powerful. And guess what? There's been a significant spike in the number of X-class flares. Now, what about solar storms, also known as coronal mass ejections? These are massive bursts of gas and magnetic fields released from the sun. The data indicates an unusual frequency of these storms, with their occurrence rate being much higher than average. What does all this mean? Well, the data suggests a period of increased solar activity. This could point towards a solar maximum, a phase in the sun's cycle where solar activity is at its peak, or it could indicate an impending solar flare or storm, both of which can have significant effects on Earth. These numbers paint a clear picture. Something unusual is indeed happening on the sun. But how is it affecting us here on Earth? Our planet, though a speck in the cosmos, is not immune to the sun's whims. This is as true as it is poetic. Solar activity has a profound impact on Earth, from creating breathtaking auroras to causing potentially disruptive events in our technology-dependent lives. Let's start with the beauty: auroras. These mesmerizing light shows are a direct result of solar activity. Charged particles from the sun interact with Earth's magnetic field and atmospheric gases, resulting in vibrant, ethereal displays of color. These particles are often ejected by solar events like flares and storms, and their frequency can directly influence the frequency and intensity of auroras. However, not all effects of solar activity are so visually pleasing. Solar flares and storms can also lead to phenomena called geomagnetic storms, which are temporary disruptions of Earth's magnetosphere. Data shows that these storms occur around 100 times per solar cycle, which is roughly every 11 years. These storms are more than just an interesting space weather event. They can cause significant issues for our technology. For instance, they can disrupt radio communications and GPS signals. They can also induce electrical currents in power lines, leading to blackouts. Satellites too are vulnerable to these storms, which can damage their electronic systems and shorten their operational lives. Recently, some unusual solar activity has been observed. Our data suggests an increase in the frequency and intensity of solar flares and storms, which could potentially lead to more frequent and intense geomagnetic storms. Just last month, a significant geomagnetic storm was recorded, which caused minor disruptions in satellite communications. While it's difficult to say for certain if this event was a direct result of the unusual solar activity, it's certainly a possibility that warrants further investigation. So we've seen firsthand that whatever is happening on the sun doesn't stay on the sun. But what does all this mean for us? We're living in a universe where even the smallest shift in the sun's behavior can ripple through our lives. Let's take a moment to appreciate the gravity of this, shall we? The sun's unusual activity, be it solar flares or storms, isn't just a cosmic spectacle. It's a game changer. It can disrupt our technology, from communication systems to GPS. It can influence our climate, tweaking weather patterns in ways we're just beginning to understand. And let's not forget about space travel. These solar tantrums can pose serious risks to astronauts and satellites alike. But here's the thing. This isn't a catastrophe in the making, but rather an invitation. An invitation to delve deeper, to learn more, to stay informed. It's a reminder that physics, especially astrophysics, is a field ripe with mysteries waiting to be unraveled. So keep your eyes on the stars, and remember, even the sun, in all its predictable glory, can still surprise us.